Hi, my name is Cameron McIntyre, and today I will be discussing the effects of Black Widow spider venom on the synapse. In order to understand how Black Widow venom affects the synapse, we have to know a few basics. Let's start by getting a foundation on what a synapse is and how it works. A synapse is the gap between two neurons where information is transferred. Synapses are involved in every nervous system function. Synapses contain a presynaptic terminal where the information is coming from and a postsynaptic terminal where the information is being transferred to. The space in between is called the synaptic cleft. In the presynaptic terminal, there are things called synaptic vesicles. These vesicles act as packages that contain neurotransmitters. These vesicles are held closely to the membrane of the neuron because proteins called snare proteins tether them. There are many different types of neurotransmitters which all play a different role. These neurotransmitters are the chemicals that are sent across a synapse and ultimately cause something to happen in the nervous system. Today we'll be focusing on acetylcholine. In order for a neurotransmitter to be released, a few things must happen first. First, an action potential must be created. When a neuron is not active, the membrane of the neuron is at its resting membrane potential. This means that the neuron is not sending any signals. When something stimulates the neuron, certain channels in the membrane of the neuron will open and allow ions, which are charged particles, to come into the cell. If the charge of the ion that enters the cell is more positive than the membrane's resting potential, it will depolarize. If this depolarizing current of ions reaches a certain point, called the threshold potential, there will be an action potential. Once an action potential is created, calcium channels open. Calcium can then come into the cell. The snare proteins that hold the synaptic vesicles to the membrane have a sensor that senses the presence of calcium. When the calcium binds to the sensor, the snare proteins cause the vesicles to fuse together with the membrane of the cell, and the neurotransmitters that were stored inside of the vesicles are then released into the synaptic cleft. In the postsynaptic terminal, there are receptors. These receptors are what the neurotransmitters bind to. Once a neurotransmitter is bound to a receptor, many different things can happen depending on what the neurotransmitter is in the specific receptor. Once the neurotransmitter has been released and bound to receptors, the excess neurotransmitters that are in the synapse must be removed in order to form a new signal. One way of doing this is through a process called reuptake. This is when the neurotransmitter goes back into the presynaptic terminal. Once the synaptic cleft is cleared, the process of synaptic transmission is complete. Now let's discuss how black widow venom affects this process. People who have been bitten by a black widow spider can experience a wide range of symptoms, including muscle cramps, pain, spasms, fevers, difficulty breathing, headaches, chest pain, stomach pain, sweating, nausea, and much more. Black widow spider bites are not very common. In 2013, there were less than 2,000 reports of black widow bites. Although not very common, black widow bites can be deadly, especially in young children and elderly people. The effects of black widow venom can be dangerous in high-risk individuals who have a history of health problems. It is important that if you suspect you have been bitten, you seek medical attention. When someone is bit by a black widow spider, a toxin called alpha letrotoxin, or ALTX, is sent into the bloodstream. LTX can bind to the membrane of the presynaptic terminal, which causes calcium to rush into that neuron. The calcium binds to the calcium sensors, which causes the synaptic vesicles to fuse with the membrane and release the transmitter acetylcholine. Acetylcholine is the neurotransmitter that is responsible for making your muscles move. LTX causes a massive amount of acetylcholine to be released. Along with a huge release of acetylcholine, the venom also inhibits the reuptake of choline. This means that the signal that acetylcholine causes does not stop. This can cause, among other things, severe pain and cramping in muscles. To measure the effects of black widow venom on the nervous system, researchers used part of adult male rat brains. They loaded black widow venom into measured out samples and injected them into the rat brains. The levels of acetylcholine were measured before and after the injection. Researchers found that there was a large release of acetylcholine when the venom was injected. They also saw that there was a decrease of choline reuptake. The researchers then injected anti-venom serum into the same brain with the black widow venom. There is a decrease in the acetylcholine levels, which shows that the large amounts of acetylcholine that is released can be reversed. The researchers did notice, however, that the reuptake of choline did not return to normal. This shows that choline reuptake will not go back to normal when given anti-venom serum. The most effective treatment against black widow venom is anti-venom serums. These are usually specific to the patient and depend on past health history along with the severity of their symptoms. Another popular treatment is muscle relaxants. While these can help alleviate symptoms temporarily, anti-venom is the most effective long-term treatment. That's all for my video on the effects of black widow venom on the synapse. Thank you for watching and I hope you learned something.